more than one variables or more than one functions are combined together to form a compound statement. This operator operates on single variable and operation performed by not operator is called complementation and the symbol is bar. These two possible values along with this result we are going to represent in the form of table, that is truth table. Dear students, welcome to CS classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, in this session, we are going to start with a new chapter, that is chapter 2, Boolean Algebra. Let us see the weightage of the chapter. One MCQ, that is multi-choice question, and 2 marks questions. There are two 2 marks questions and one 5 marks question. So totally there are 4 questions and weightage is total of 10 marks. So this is an important concept, important chapter. So weightage of the chapter is 10 marks. In this chapter, we are going to learn some of the important concepts like what are Boolean variables and Boolean constants, logical operators, Venn diagram, basic logic gates, basic postulates of Boolean algebra, De Morgan's theorems, min-term and max-term, canonical expressions, and simplification of Boolean functions or equation using K-map. See, these are the few concepts we are going to cover in this chapter. Now, let us start our discussion with the definition of Boolean algebra or about Boolean algebra. So what is Boolean algebra? This Boolean algebra that deals with binary number system. Now, you know what is binary numbers. 0 and 1 are called binary numbers. So this algebra, it is known as Boolean algebra. And what is the use of this? It is used for designing a logical circuit used by the processor of computer system. You know what is a microprocessor? Microprocessor uses these type of Boolean algebra or logic circuits designed by using different types of logic gates. So that is the importance of this Boolean algebra. And here we are going to learn elementary logic gates that is used to build up circuits of different types, perform different operations. Here in this chapter, we are going to learn what are all logic gates and different circuits can be built by using these fundamental or elementary logic gates. So we can have different logic circuits for different operations. So these are the logic circuits used by microprocessor for its arithmetic and logical computation or processing. It is used to design simple logic circuits, which these circuits are frequently used by ALU for processing. See, this is introduction to Boolean algebra. Now let us learn few terms like what are variables and what are constants in Boolean algebra. In Boolean algebra, a variable is used in Boolean algebra or Boolean equation can have only 2 possible values. See, it is a type of a variable where it can store only 2 possible values. Here, those 2 possible values are either 0, we refer it as false, and or 1, or it is true state. So these are the 2 values or signals used by this variables in Boolean algebra for its processing. So the truth values are depicted by logical constant true or false, 1 or 0. See, these values are called truth values. What are truth values? The possible values for a variable, either 0 or 1, called truth values. And here, next truth table. Truth table is a table which represents all the possible values of logical variables or statements along with all the possible results for the given combinations of values. Here, what is the truth table now? Now we know what are truth values. 0 and 1 are called truth values. These are the values stored or used by a Boolean variables. So here, these all the possible values of the given equation, we are storing it in the form of a table that is nothing but truth table. So another way, in other words, we can say truth table is table of truth values of truth function. So for any function or Boolean function, we can represent all the possible results along with different combinations in the form of a table that is truth table. So here Boolean variables and Boolean constants. Here 0 and 1 are nothing but values, they are constants. Let us move on to next slide. Here we are going to learn the definition of compound statement. What is a compound statement? Here, look at the definition. A logical statements or truth functions are combined with the help of logical operators like and, or, and not to form a compound statement or logical function. Now, what are logical statements or what are truth functions? And here, more than one variables or more than one functions are combined together to form a compound statement. For example, look at this example here. Here, x and y and z, these are the variables. And these variables are combined to form a logical expression or compound statement. How we are going to combine this? These logical variables are combined with the help of logical operators. Which are those logical operators? And, or, and not. So, these Boolean variables or logical statements are combined with logical operators to form a compound statement. Now, look at the example here. For example, x, not y or z. This is here x and y and z all are Boolean variables are combined with the help of not operator as well as or operator. And in another example, y and x or z. Here, y, x, z or one more, these are our variables and we are combining all these things by using and or logical operators. So that is the definition of compound statement. It is these Boolean variables are combined with the help of logical operators to form a compound statement. Now look at the truth table here with x and y are the variables and r is the result. So here these are the different combinations of input variables and these are the result. So this is a truth table where we are going to store all possible combinations of truth values. Now, we are going to learn another definition of what is tautology and what is fallacy. Now, if result of any logical statement or expression is always true or 1, it is called tautology. And if the result is always false or 0, it is called fallacy. Now, look at the previous slide here. This is a truth table and these are the possible values and these are the results. So, results are stored in one of the column in the truth table or is the result. So, in this result, we can find different results like 0 and 0, 0, 1. So, in this example, it is false, false, false and true. As per the definition here, if result of any logical statement or expression is always true, it is called tautology. What is the meaning of always true? In this truth table, all the values of a column must be true. I repeat once again, in any of the truth table, in the result column, if all the results, all the values are equals to 1, then we term it as a tautology. And what is fallacy? Here, if the result is always false or 0. In this example, if you look at the same truth table here, the result column, last column must have all the values must be 0. Then that truth table or values are called as fallacy. So this is the definition of tautology and fallacy. Next, we move on to logical operators. Now, in previous slide, we have learned what a compound statement, and these are combined with logical operator. Which are those logical operators? Logical operators are not, or, and. These are the logical operators. Now let us see the definitions, or what are the operations of logical operators. Now this is the one operator, not operator. What is not operator? This operator operates on single variable, and operation performed by not operator is called complementation, and the symbol is bar. So the operation performed by not operator is called complementation, and we represent with bar. Here, look at this diagram here. See, this is the truth table, and what are the possible values here? X is one input, and this is x naught is the output. Because not operator, it works only on single variable, or single variable, x variable, and this is the output. So this is the complement of this. What is the meaning of complement of this? If you know that there are two possible values, either 0 or 1. If it is 0, complement of 0 is 1. If the input variable value, truth value is 1, complement of 1 is 0. So this is how we represent in the truth table. So this is the operation of not operator. Now let us say one more definition, Venn diagram. What is a Venn diagram? So it is a diagram representing logical sets, particularly as a circle or closed curve with an enclosing rectangle. Look at this. We are representing these values or complement of this operation in diagram that is called Venn diagram. Here we use circle and it is enclosed within a rectangle. So this is a Venn diagram for not operator or not operation. Now let us move on to one more operator, that is OR operator. What is OR operator? An OR operator which denotes operation called logical addition, and symbol is plus, and it is not arithmetic addition. It is not arithmetic operation. So here, what is OR operator? OR operator, the operation is called logical addition, and it is not arithmetic addition. So the symbol what we use here is plus. Now look at the truth table here. In the look at truth table here, x and y, these are the two variables, and if there are two variables, there are four different combinations, that is 0, 0, 0, 1, 1, 0, or 1 and 1. And here x plus y, this is the result of the OR operator or OR operation. So here, what is the OR operation? 0 plus 0 equal to 0. Here 0 is one variable, one more variable is 0, values are 0, and in between plus is called operation. If both the variables are 0 and 0, output would be 0. And here 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. So based on this operation, now we can compute this column, we can write the output for this combination. So here accordingly 0, 0 is combination, output will be 0. 0 plus 1, 0 plus 1 is 1. 1 plus 0, 1, and 1 plus 1 is 1. So this is called OR operation. And here, this is a Venn diagram. Here we are representing these operations by using Venn diagram. Next operator is AND operator. AND operator performs logical multiplication, and symbol for AND operation is dot. So here it is logical multiplication, and here symbol we use is dot. Now look at the truth table here. There are two variables here, x and y, as we have seen in the previous example, previous slide. Here four combinations and the result. How do we get the result? The result is we get it with the help of AND operation. how it's going to operate, what would be the result of this? Here 0 is one variable, one more variable 0, and in between dot represent AND operator or AND operation. So similarly 0 0 0. By looking at this operation, we can fill this or we can write the result of this combination 0 0 0 0 1 0 1 0 0 1 1 1. So this is called logical multiplication. This is AND operation. Next concept is evaluation of Boolean expression using truth table. Now at this stage, you know what is a truth table. It is combination of different inputs and the result of different combinations. That is truth table. Now, how do we write the combinations for the given Boolean equation or Boolean expression? In this example, a truth table involving two input variables will be having 2 to the power of n, that is 4. Here n stands for number of variables. So 2 to the power of n. In this example, x and y, there are two variables. So 2 to the power of n, 2 to the power of 2, that is equals to 4. So for two variables, we can have 4 different combinations. So this 0 0 1 1, 0 1 1 0. This is one of the method of writing different combinations for given number of variables. Now similarly, we look into the one more truth table here. The truth table involving 3 input variables. Again, formula remains the same. So this is 2 to the power of 3, 8. So it is possible to have 8 different combinations for given 3 variables. And generally, how do we write it here? If there are 8 combinations, so half of 8 is 4. In the first variable, we fill first 4 zeros, and other remaining 4s we fill it with 1. So 4 plus 4, 8 combinations or 8 possible values for one variable x. Similarly for y, second variable here, and here half of 4 is 2. So we write 2 zeros, 2 ones, 2 zeros and 2 ones to make 8 combinations. And next column is, it is z, third variable, and here half of this 2 is 1. So we write 0 1, 0 1 alternatively. So this is how generally we write truth table for given number n number of variables. Next, we move on to basic logic gates. What is a logic gate? A gate is simply an electronic circuit which operates on one or more input signals and produce an output signal. So this is electronics. What is a logic gate? It's nothing electronic circuit. Now at this stage, you know what is electronic circuit. These are the circuit designed or constructed with the help of basic gates, okay, or basic operator or basic operations. So these are the circuit used by microprocessor in computer system. So, and how it's going to work? This is going to work or is going to operate on one or more signals, or we can say one or more input. Means one or more input signal and always produce one output signal. So that is the definition of logic gate. What is a logic gate? It is an electronic circuit or digital circuit used by the microprocessor in the computer system. And how it is going to operate? It operates with 2 or more input signals and always produce one output signal. That is the basic definition of logic gates. And these logic gates, the input signals are maybe there are 2 states for that, and one is 0 and one is 1. These 2 are binary numbers. So 0 stands for low voltage and this 1 stands for high voltage. And now what is the meaning of this? These electronic signals, it can be of, there are 2 states for this. One is 0 and another one is 1. 0 and 1 are called binary numbers. So here 0 we refer it as a low voltage state, and one we refer it as high voltage states. So this is what normally we use in Boolean algebra. And here, if you look into that, there are three basic gates, or there are three fundamental logic gates. They are NOT gate, another name is inverter gate, OR gate, and AND gate. See, this is a logic gate. It is electronic circuit which accepts two or more signals and always produce one output signals. And all output signals or input signals, it takes only either of two states, either 0 or 1. So there are three basic gates or fundamental gates: NOT gate, OR gate, and AND gate. Now let us see these basic gates with symbols and truth table. First one is NOT gate. Another name of NOT gate is inverter gate. So what is NOT gate? The definition is, it is a gate with only one input signal and one output signal. So this is the logical circuit or symbol for NOT gate or inverter gate. Here it takes always one input and always produce one output. So the output state is always the opposite of input state. Now here, as I told you just now, there are two states, that is 0 and 1. So here, either this we refer it as low, this is high state. And what is the definition of this? The output state is always opposite of input state. Suppose in this example, if input is 0, opposite of input is 1, so this will be the opposite of 0, this is the output. Suppose if input is 1, opposite of input is 0, output would be 0. So here, this is the logical symbol for NOT operator or NOT gate. And these values, here I write once again. See, there is one variable x here. If there is only one variable x here, that is n, that is equal to 1. Here, 2 to the power of n, that is 2 to the power of 1, that is equals 2. So this is how we can calculate number of possible combinations. So in this example, there is only one input variable. So there are two possible values. Which are the two possible values? I write here, one is 0 or one more can be 1. So if this input is 0, what would be the output of this? As per the definition, it is opposite of input. So opposite of 0 is 1. So this is one output here. If input is 1, output would be 0. These are the two possible values. So these two possible values, along with this result, we are going to represent in the form of table, that is truth table. Now we can see here, x is one variable and these are the combination. 1 is 0 is one combination, 1 is one combination. If this is the 0 is the input, output would be 1. And if 1 is the input, output will be 0. So this is NOT gate, inverter gate with logical symbol as well as truth table. Now let us move on to one more gate. This is OR gate. This OR gate has two or more input signal but always produce one output signal. That is OR gate, and this gate gives the logical addition of the input. Logical addition, just we have seen in our previous slides, that is OR operator or OR operation, that is logical addition operation. That holds good here. So here, if any of the input is high, output is high. That is the definition of OR gate or OR operation. Now the OR gate has two or more input signal but always produce one signal. The output will be the logical addition of the input. This is the definition of OR gate. Now let us see the logical symbol for this. This is the logical symbol for OR gate, with this A and B are two input and F is the output. And here we use the operator plus, logical addition plus. So output of is F, or we represent A plus B. A is one variable, B is another variable. This is two input OR gate. Similarly, 3 input OR gate and 4 input OR gate. And for 3 input, it is A plus B plus C. That is F. That is the result. So these are the logical symbol. Now let us see the truth table for OR gate. The truth table for 2 and 3 input OR gate. Now there are 2 input. If there are 2 input, means if n equal to 2, 2 to the power of n, that is equal to 2 to the power of 2, that is equals 4. So we can have 4 different input combinations. Now let us see that here x and y are the 2 variables, and here we represent this with plus, this OR gate or OR logical addition operation. So here, what are the different combinations? 2, 0, 0, 1, 1, 0, 1, 0, 1. So here there are 4 combinations. Half of 4 is 2. We write for first variable 2 zeros, 2 ones. Then half of 2 is 1, 0, 1, 0, 1. So then what would be the result of this output signal for all this combination? By looking at the definition, we can say that if any of the input combination is high, output is high. High stands for binary values or truth value 1. If you look at this combination here, 0 and 0, so output will be 0. Now 0 and 1, in all these combination, at least one of the input is high, definitely output would be high. So this is a truth table for OR gate or logical addition. Now similarly, we can look into the truth table for 3 input OR gate. Here x plus y plus z, plus stands for OR operation, x and y. There are 3 variables. If there are 3 variables, n equal to 3, that is 2 to the power of 3, that is equals 8. So we can have 8 different possible combinations for 3 input OR gate. How do we write it? As we have seen in the previous example, half of 8 is 4. We write first 4 zeros, next 4 ones for first variable. For second variable, it is half of 4 is 2, 2 zeros, 2 ones. Then here for third variable, half of 2 is 1. We used to write 0, 1, 0, 1, 0, 1. These are the different possible combinations. And what would be the result of this combination here? As per the definition, if any one of the input is high, output is high. Accordingly, if you look into that, in first combination, none of the input is high, output will be 0. In rest of this combination, there is at least one input combination is high, so result will be high. So this is the truth table for OR operator or OR gate. Similarly, now let us move on to one more operator, that is one more logic gate, that is AND gate. This AND gate can have 2 or more than 2 input signals, and always produce one output signal. And when all the inputs are high, output is high, otherwise output is 0. That is the definition of AND gate. Here definition says that in any of the input combination, all variables, all input values should be 1. If all the input combinations are 1, then output is 1 or high, otherwise 0. Now look into the circuit diagram, and here this is a 2 input AND gate, F is the result, and here we use the symbol dot here. So this is A dot B. Here dot represents your AND gate or AND operation, and this is logical multiplication. In previous example, it was logical addition, and here logical multiplication. This is the truth table. This is 3 input logical symbol, and this is 4 input AND gate. Now let us see the truth table for this. 2 variables. There are 4 different combinations, 0, 0, and look at the output here. Here, x dot y dot stands for logical multiplication or AND operation. So here, as per the definition, if both the inputs are high, output is high, otherwise 0. That definition holds good here. Accordingly, this is the truth table for AND gate. Now, truth table for 3 input AND gate. Now let us say 3 input AND gate. X, Y, Z are the input signals or variables, and X dot Y dot Z, here dot represents your logical multiplication or AND gate. So here different possible combinations and result as per the definition. If all the inputs are high, output is high, otherwise 0. Accordingly, in this combination, only last combination will be having all the inputs are high, so result will be high or 1. For rest of the things, we have to fill with 0. So this is AND gate, this is logical multiplication is the operation. We will continue our discussion in our next session. Thank you very much.